Hello students, welcome to the second video in Unit 7, and today in class we'll talk specifically how to graph a function with transformations. So the steps are: determine the parent function. What does this mean? In this class we'll typically talk about parabola, y equals x squared, or an absolute value, y equals absolute value of x, which is your v shape. And then we'll graph it. So parent function means that's where things are coming from. Step 2, determine which way the graph opens. Again, if there's a negative in front of x or x squared, the parabola opens down. If it's positive, parabola opens down. Vertical and horizontal shifts, we'll talk about this. We can also have stretch or shrink. It can become narrower or wider. And I think the most important step is actually the vertex. Step 5, determine the vertex. The vertex is the most important point on a parabola. And then the last thing, we will plot the vertex and create a table of values and then sketch it. In this class, we will ask you to plot 5 points. So 2 points to the left of the vertex and 2 points to the right of the vertex. Let's just take a look at the example, because if you don't look at the example, it's really difficult to explain this. So question number 1, I would like to graph f of x equals x plus 1 to the second power minus 9. So the parent function, okay, step 1 would be y equals x squared. And I am going to graph the parent function using dotted line. Okay, 3 comma 9, negative 1, negative 1, negative 2, 4. They should be symmetric. So the parent function should look like this. Okay, arrows at the end. Determine which way will this open, up or down, and the answer is up because of this number. There's like a 1 in front of it. So this, I would say, opens up. The next one is determine the horizontal and vertical shifts. Plus 1 means one left, and minus 9 means down 9. Okay. Step 4, determine the whether it's narrower or wider. Since this is 1, it's really not going to affect the function, so no change. It's not going to be narrower or not wider. Okay, number 5 is where is the vertex. So look at this. I said 1 left, down 9. The original vertex is 0, 0. So vertex of the parent function is 0, 0. So if I go 1 left, it becomes negative 1. And if I go down 9, is negative 9. So this is the most important point. Okay, let me change the colors and maybe pick red. So your new vertex is negative 1, negative 9. That's your new vertex, okay? And step 6 is the most time-consuming step. We want to create a table of values, okay? So x and y. Now in this class, we want 5 ordered pairs. So I will put negative 1, negative 9 here. And I want 2 points to the left of negative 1, which could be negative 2 and negative 3. Again, try not to pick huge numbers like negative 10, because once you square negative 10, you technically get 100, and we have no space to graph y equals 100. And also pick 2 points to the right, so you can pick 0 and 1. So now let's evaluate this. When x is equal to negative 3, y will be equal to negative 3 plus 1 to the second power minus 9. So I'm going to show you the steps for this example only, okay? So y equals negative 3 plus 1 is negative 2 to the second power minus 9. Now be careful. Negative 2 times negative 2 is positive 4 minus 9. Okay? And 4 minus 9 is negative 5. So when x is negative 3, y is negative 5. So the order pair would be negative 3, negative 5. Let's plot this. You go negative 3, negative 5. Okay? Now, when x is negative 2, okay? So let's do this in our head. Let's use this function over here. When x equals negative 2, what's negative 2 plus 1? Negative 1. What's negative 1 times negative 1? Positive 1. So this gives you 1. What's 1 minus 9? Negative 8. So when x is negative 2, y is negative 8. So the order pair would be negative 2, negative 8. Okay, we already know what happens here. That's your vertex. Now, do you recall that parabolas are symmetric? So if negative 2 gave you negative 8, 0 should also give you negative 8. But let's check it. If you put 0 for x, what's 0 plus 1? 1. What's 1 to the second power? 1. What's 1 minus 9? Negative 8. Okay? And when x is 1, 1 plus 1 is 2. 2 to the second power is 4. 4 minus 9 is negative 5. So this would be 0, negative 8. And this would be 1 comma negative 5. So 0, negative 8 would be actually your y-intercept. And 1, negative 5 would be here. Okay, do me a favor. Look at the dots. Are they symmetrical with respect to the vertex? Yes, it is, because the vertex goes through negative 1, negative 9. So your graph would look like this. Okay, this graph is shifted 1 to your left and 9 down. So just so you know how much work we did to do this. Okay, so on your test or quiz, you have to show all the steps. Here, I don't have that much space, so I was trying to do things in my head. But I showed you how to get the value of y when x is equal to negative 3. Let's take a look and do example number 2. So number 2, if you noticed, it's still a parabola because it's x squared. But what you notice, there's a negative number in front of x, and also it's a fraction. It's 1/4. So we will have other things in this case. So first step, determine the parent function. The parent function is, let me actually use black so I'm consistent. So the parent function would be, this is question 1. So the parent function would be y equals x squared, okay, which is a parabola. Second step, this will open down. Opens down. And how do I know it? A is negative. Step 3, determine the horizontal and vertical shift. Now, horizontal, in parentheses, you get x minus 0. So no horizontal shift, but there is a vertical shift, which is up 1. So move up 1. Determine the stretch or shrink. Okay. This means you will shrink by 1/4. So, probably the most important thing is, where is the vertex? The vertex would be, since I'm not moving left or right, I'm only moving one up. The vertex would be 0, 1. Okay, so just so you know, the parent function looks like this. Quick sketch. Okay, now the new function, I will use ret. The vertex is 0, 1. So that's your new vertex. And now let's make a table of values. So x and y. So vertex is 0, 1, so I'm gonna put in the middle. And I want some points to the left. And also I want some points to the right. Now, what points should we pick in this case? Should we pick even numbers or odd numbers? Okay, in this case, it's actually easier to work with even numbers. Why even? Because even number to the second power will be also an even number. Okay, and it's always easier to take 1/4 of an even number. If you pick odd number, let's say 3, 3 squared is 9, and 1/4 of 9 is not as easy to calculate as 1/4 of an even number. So I'm going to pick -2, and I am going to pick -4. So let's start with -4. What happens when x is -4? You get -1/4 times -4 to the second plus 1. Now think about the word PEMDAS. First we do what's in parentheses. What's -4 times -4? Positive 16. So -1/4 times 16 plus 1. Now multiplication. What's -4 times 16? That's -4 plus 1, which is equal to -3. Okay? So when x is -4, y is -3. Let's plot this. -4, -3 will be over here. Now when x is -2, I will do this without showing steps. -2 times -2 is +4. -1/4 of 4 is -1. And -1 plus 1 is 0. Okay? Now, since this was my vertex, okay, this point will be -2, 0. Since this is my vertex, typically I want to pick points that are symmetric. So if I pick -2, 2 to the left of 0, I will pick +2. And if I pick -4, I will also pick +4. Okay? So when x is 2, 2 squared is equal to, let me show the steps here, I got some space. When x is 2, I get y equals -1/4 2 squared plus 1. Please remember, we are working with exponents first. So you do -1/4 times 4 plus 1. -1/4 plus 4 is equal to -1 plus 1. And that's how you get 0. Okay, so let's plot this. 2, 0 would be here. I also had -2, 0. And the last one, if you pick 4 for x, quickly, 4 squared is 16. -1/4 of 16 is -4. And -4 plus 1 is -3. So 4, -3 is here. And now if you connect this, you will get a graph that looks like this. And you could see it opens down. But you can also see that it's a little bit wider. Okay, so this graph is the graph becomes wider, which is also called a vertical shift. I have two more examples, but you kind of got the idea. For number 3, all I really want to do is talk about the main idea here. It will open up, okay? The tree tells you it will be narrower, so the graph would be a vertical stretch and the graph will become narrower. But let's also talk about the shifts. This x minus 4 means right 4. This plus 6 means up 6. So the most important thing is, where is the new vertex? The new vertex will be 4, 6. And then you can make a table of values. And if you want to practice, okay, you can pick 4, 6 is your vertex. So maybe pick a point 3 and 2 and pick 5 and 6. Okay, you can evaluate for y and you can graph it. You can always check your work on a graphing calculator or Desmos. And the last one, the parent function's absolute value, which will be v-shape. It will open up, and let's talk about the vertex. The vertex in this case would be x minus 2 means move right 2, plus 5 means up 5. So the new vertex will be 2, 5. And if you want to create a table of values, okay, 2, 5, you can pick a point to the left. So you may pick 1 and 0, and you may pick 3 and 4. Okay. So thank you for watching this video. I think the hardest thing is to come up with the vertex, because if the vertex is incorrect, your problem is, you will not do this correctly. And then you have to make a table of values, evaluate for the value of y. So again, thank you for watching this video and have a good day.